Let's go to our final, or last but not least speaker is Dr. Chanuki Illushka Seresinhe. She's a visiting researcher at the Alan Turing Institute and the director of data science at Culture Trip. She's bringing to us a presentation titled AI to Understand Beautiful Places and Our Wellbeing. Chanuki, take it away.
Great. Well, thank you so much for the introduction. So I'll just get going. So yeah, so for centuries, I just realized, so for centuries, humans have expressed their appreciation for beauty in their art, literature, and philosophy. Governments around the world, they value beautiful places as evidenced by protection of beautiful places. And also architects and designers often emphasize not only the utilitarian function of buildings, but also the aesthetics of the buildings they create as well. So it's pretty clear that beautiful places are really important to us because, we do seek them out ourselves, just even when we want to just lift our well-being. But until now, we haven't actually been able to provide any quantitative evidence on a large scale supporting the idea that beautiful places might actually be beneficial to humans, as we previously have been lacking data on the beauty of our environment. So normally when we look at data on the environment, we tend to focus on things that are a bit more easy to measure. For example, green space, distance of parks, land cover types, or measures of biodiversity, because they're objective and you can kind of quantify them on a very large scale. But you can imagine that if you wanted to gather data on the beauty of an entire country, that's a lot more difficult because you normally would have to ask people, is your neighborhood beautiful or not beautiful? But luckily these days we spend a lot of time on the internet. So now the internet has become a really fantastic source of actually allowing us to gather data. So I was really excited to come across this website called Scenic or Not. And it's this website that basically people can rate images between 1 and 10. But what's happening in the background is that we have an image for every square kilometer of Great Britain. So by the time I came across this data, there are about 217,000 images with about 1.5 million votes. So it's quite a nice, quite solid data set of beautiful places around the world. And so if we map this data out, you will see kind of patterns emerging. And it tends to be the places, people might like to go on holidays, or people might like to go hiking. So you've got the Lake District and the Peak District. You also have areas like Somerset and Devon, for example, as coming out as being quite beautiful. So even that one image is giving us quite a good sense of data. But I'm really interested in understanding what beauty might mean for people that might live in cities, because most of us, and then the end of the day, do live in cities. And if we think about one image per square kilometer in a city, that's really not going to be representative of beauty in an area. So I was wondering if I could actually generate beautiful ratings. So I wanted to use convolutional neural networks to help me predict the beauty of new images that we don't have any ratings for. So normally when you train convolutional neural networks, you tend to need millions and millions of examples. And I only have about 217,000 images. So I use a technique called transfer learning. And with transfer learning, all you do really is that you can train a neural network that can already do something quite similar to learn how to do a slightly different task. So with this neural network, the base neural network is actually something called Places. So it's from MIT, and it can already do a very good job of actually recognizing different types of place categories, for example, tower or bridge. So I basically then retrained this network instead to predict beautiful scores, and it did a pretty good job. So it was actually able to predict where the beautiful places are around England at a higher scale. So let's look at what the results look like. So I wanted to kind of just give the neural network all the images I could find of London. So I sourced these images from Geograph, and I kind of mapped them out. And I wanted to see, are the predictions going to be intuitive for what we might find beautiful around the city? So one of the areas right now, especially in lockdown, I like to go to walk to is Hampstead Heath, and because I find it very beautiful, I find it uplifting to visit. And if we look at how the neural network does to predict beauty in the area, you'll see all around Hampstead that's predicting beautiful places. So purple is like super scenic, green is very scenic, and gray is not scenic. So all around we've got the roads and that's networks, and that's not coming out as scenic. But you do see beautiful areas, for example, this lake, the Hampstead Heath ponds, as coming out as being a beautiful image that the neural network can pick up. So let's look at how this looks like across central London. You'll see, obviously, of course, parks are going to come up, but there are some trails that I saw, and there were these paths where there's tons of green dots, and I was wondering, like, what is that? Like, was that like a really beautiful road? And well, it turns out it's Regent's Canal. So it's not only picking up on beautiful parks, of course, that are nice to spend time in, but other types of beautiful structures as well that we might find beautiful around a city. And then finally, it knows to tell the difference between, it's not just picking up on the beautiful park just because there's green, there's grass in the area. It can tell, like, if it's a green area, but if it's next to a network, or if it's looking a little bit dilapidated, it's able to kind of differentiate the difference. And then finally, I also looked at kind of was honed in on some more built up areas. So for example, Tower Hill is a very beautiful area as well. And, it's also picking up that characterful building should also be beautiful. So it's done a really good job of kind of, helping to predict beauty around a city in quite a flexible way. So if we look at the predictions I have for the images in GeoGraph, you'll see, okay, it is doing, a good job, but the GeoGraph images are still kind of sparse in certain areas and a bit spread out. Again, not really great for research purposes because some areas are not represented here. So I wanted to try and use Google Street View images instead. So when I immediately trained the neural network, before training, I just gave the neural network images from Google to predict, and it just couldn't get it right. It was, the accuracy dropped to 0.26, and it was just really getting confused. And just generally, when you're training neural networks, they're very sensitive to the type of image. So a GeoGraph image is a certain type, and Google Street View images are actually kind of images stitched together. There's a lot of distortion in the image. So that was actually kind of making the convolutional neural network confused. It looked like a completely different image for the network. But very simply, you just had to gather more data. So here we just kind of, all we need to do is gather another few thousand images with Google Street View Network, and we got them rated, and it improved the accuracy. And then I was able to kind of build like a very good map. Like, if this is London, and I know where the beautiful areas are, and I know where the beautiful areas are not. So it kind of helped to give a nice representative ratings. So yes, it turns out that beauty isn't in the eye of the human beholder only. You can actually train AI to recognize beauty, which was kind of surprising, but not too surprising because there are some patterns as to what we prefer. So one of the kind of papers I kind of wanted to use this kind of beautiful ratings was to look at beautiful environments have a quantifiable association with increased happiness. And I had this like really great data source to work with. And this is data from an app called Mappiness that was built by Jordan McCarran and Susan Murata when they were at the LSE. And here people are just pinged 2 times a day and they report how happy, relaxed, or awake they are. I was focusing on happiness. And they also answer a few kind of questions like, are you alone? Are you, with your spouse or your children? And basically, what are you doing at the time? Are you working? Are you, doing errands, traveling? So it's quite a rich data set to kind of work with. So if you look at kind of happiness over time, you'll see basically, people are not so happy in January and February, and they start to become a lot more happy in the summer. And if you look at happiness over the week, obviously people are much more happier on the weekends, less happy on Monday, Tuesday, and Wednesday, I guess, when you're working. Just kind of, I guess, how it goes. So it was just a really fun data set to work with. So the way I did the analysis, I used was a fixed effects analysis, and I'm measuring because I'm able to measure happiness in real time for each individual. And I can control for a range of variables such as, whether they're at home or at work or activities they're doing, because the website, the mobile app is actually quite rich with the data it collects. But luckily, because it is a mobile phone app, you also have the GPS signal giving you the latitude and longitude as well. So we can use this to link with other types of data that we also want to control for. So for example, I want to know if somebody's happy because they're in a beautiful area, not just because they're happy because they're it's a sunny day and they're basically out with their their spouse, for example. So we want to kind of hone in as much as possible to look at the effects of the beautiful place itself. And it worked out. So it turns out that we were able to show that individuals are significantly happier when they visit environments that are more scenic. And this did actually held as well for built up areas as well. because that's what I was very interested in. Is that I didn't want it to be that you only can go to the countryside, and of course there you're going to be happy. I wanted to see that this actually helped in the cities, and it does. So what are the implications for policy with this research? So can we use AI to understand what is actually beautiful? So again, I went back to my data because I have about 217,000 images. So I want to understand, what are we finding beautiful? Are we able to use that to provide anything that's kind of meaningful as a guidance? Again, I went back to that neural network before that I mentioned from MIT called Places, which does a really good job of predicting different types of places. And I also can extract another level of features here as well. For example, is it a man-made or natural? Is it an open area? As well as many different things about the kind of the material as well. So it's quite a rich kind of bunch of variables that I get to work with here. And when we look at the results, this is what we find. So unsurprisingly, of course, we find natural scenes such as coast, valley, mountains, and forest trees as being beautiful. But surprisingly, we do actually also see this built-up environments as well, aspects of the built-up environment. So for example, characterful buildings such as cottages. This is all English data, so that's why it's typically we get cottages in there, but also lighthouse as well. And also bridge-like structures such as viaduct and aqueduct were coming out as being rated as more scenic from people. If we look at what's unscenic, unsurprisingly, of course, it's the kind of industrial highways. People are kind of rating the images down for that reason. But interestingly, we also see this, there were features we can also extract from the neural network. So we get no horizon. So if you can't look out into the view, people actually rate it down. I thought that was really interesting. And something we saw with the neural network when I was making its predictions, that just because it's green doesn't mean it's really beautiful. In general, people are rating pictures down if the area of grass is flat and it's just uninteresting as well. So, so what can we say with the evidence we have so far? So yeah, we can say something about green space. So of course, flat and interesting places are not necessarily beautiful. Green spaces that contain trees and valleys and contours are more pleasing to the eye. It might be worth investing in these characterful buildings and beautiful bridges. It might not be a complete waste of money because they might be linked with us having a boost in our everyday happiness. But what I'm really actually trying to do now, and this is mainly work with Stephen Law because I'm mainly working commercially for the most part. So we're actually trying to look at architectural features as well because we'd like to give more meaningful advice to policy. So one of the things we're looking at is also one architectural feature we can pick up on is blank versus active frontage. And here, a blank frontage is when you walk down a street and it's got like walls and it doesn't look like you can actually interact with the space around you. Where with an active frontage, there's windows, there's doors, it feels like a place where you can interact. And if we look at how it correlates with beautiful places, there is a strong correlation between active frontages versus building frontages. So it is still early days, but I'm really excited basically about what we can do with AI. And mainly because in the past, the design decisions for buildings and city infrastructures have been limited to opinions of few people, right? So it's been, maybe the mayor, the city planning officers, architects, builders, but these design decisions actually impact millions of people. So I think it's really great how we can use AI to gain insights that were previously unfeasible from the preferences of tens of thousands of people to inform how we might design beautiful places that we actually want to live in. So that's it for me.
Thank you very much, Chanuki. That was really fascinating. We've got a lot of questions through Slido, but we only have about 1 or 2 minutes for questions. So you can either do them short and we can get through a lot, or it's up to you, but just as a heads up. So the first one that has 11 votes, so a lot of people want to know the answer, is from Leah. How are you defining beauty?
Oh, so I'm not defining beauty. I'm letting the model tell me what defines beauty. So this is where I'm extracting features from the neural network. And then I'm doing a statistical analysis and then trying to figure out what's actually beautiful. So I think that's interesting because we can crowdsource the idea of beauty and actually we can understand what a collective understanding of beauty is, because I think that's really important, especially when we're trying to go to policy decisions with that.
Brilliant. Another question with a lot of votes from Mark. Does the lighting of the images make a significant difference, i.e. sunset or sunrise light as opposed to midday or sunny to overcast days?
So we did do a statistical analysis in general just to make sure image quality wasn't making an impact, and it didn't look like it did. But sometimes context does matter. I mean, luckily we're using images from Geograph. Like originally we're using images from Geograph, and they tend to be quite stable. But the better images is actually Google Street View, because they just do them all like in one go. And you can kind of hope that you don't get that much variety. But of course, I think sometimes I've noticed if it's snowy, somebody would have rated it up, and it's not about the context. It's because the snow just makes everything look beautiful. So there is a little bit of that in the data.
Fair enough. Fair enough. Another question from Trish. This is fantastic. Is your rated map available for the wider public?
Unfortunately not, but I mean, all the papers are available. So yes, you can kind of have a look at that. I did actually have a website where I had it working, and then it stopped working, and then I didn't have time to update it. I don't know. Maybe if there's a web developer out there that wants to help me, I'd be happy to release the data and they can create a map for people to explore.
There you go. Awesome opportunity for someone. Okay, I'm going to do one final question from Keith. How have you considered the historic environment, e.g. historic buildings, as part of including human constructs in measures of positive environments?
So I don't really I just take whatever buildings are there at the time period. I'm not looking at very specific styles of buildings. I have to say the data is probably biased more towards historical buildings because we're taking images from all around England. I would be very interested in doing this research in other countries, especially where there might be modern architecture, and seeing, what happens. There are probably certain biases with the research because England definitely has a lot more historical buildings and these really charming buildings as well. So that is something to kind of keep in mind with some of our findings.
Chanuki, thank you so much. I'm so sorry to cut you short. Anyone who's had more questions over here in Slido that we didn't get time to get to, I'm sure Chanuki would be happy to take questions, or you can get in contact with her on Twitter or email or whatever is best.